Finding 65 volts at a light fixture when the switches are off can be concerning. Several factors can contribute to this issue. Firstly, a neutral conductor may be crossed with a live conductor. This situation can create what is sometimes referred to as the bootleg ground, which allows voltage to leak onto the neutral circuit. Secondly, induction from nearby wiring can cause this. If live wires run in close proximity to neutral wires, electromagnetic induction can transfer voltage onto the neutral line. Thirdly, a ground fault in the switch or the fixture itself might be the culprit. A loose or broken ground connection can result in voltage flowing back onto the neutral circuit. Fourthly, capacitive coupling could be responsible. In certain wiring configurations, capacitors in electronic devices can create a path for voltage leakage onto the neutral circuit. Now, let's address whether some leakage is normal. Small amounts of leakage, generally considered to be less than 10 volts, can be normal in certain circumstances. However, excessive leakage, meaning anything over 10 volts, indicates a problem that should be addressed promptly. Here are some recommended actions that can be taken to identify the problem. Firstly, turn off all affected switches and circuits. This ensures a safe environment for testing and troubleshooting. Secondly, confirm the voltage using a voltmeter. A voltmeter is essential for accurately measuring the voltage present in the circuit. Measure the voltage between the hot wire and the ground wire, and then measure the voltage between the neutral wire and the ground wire. These measurements can help identify the source of the voltage leakage. Thirdly, disconnect the light fixture. Isolating the fixture from the electrical system helps eliminate any potential issues within the fixture itself. If the voltage disappears when the fixture is disconnected, the problem likely lies within the fixture. Fourthly, carefully inspect all wiring connections. Ensure all connections are tight and secure, with no loose or broken wires. Loose connections can create resistance and lead to voltage leakage. Fifthly, test for ground faults. Use a ground fault circuit interrupter, also known as a GFCI, to check for any ground faults in the circuit. A GFCI is designed to detect even small amounts of current leakage to ground and will trip, indicating a ground fault. If, after following these steps, you are unable to identify the cause of the voltage leakage, it is strongly recommended to consult a qualified electrician for further troubleshooting and repair. Electricians have the expertise and specialized tools to diagnose and resolve complex electrical problems safely and effectively. In addition to these potential causes and troubleshooting steps, it's important to understand some basic electrical concepts related to this issue. The neutral wire is intended to carry current back to the source, ideally at or close to 0 volts. When voltage is present on the neutral wire, it indicates that something is disrupting the normal flow of current. This disruption can be caused by a variety of factors, as mentioned earlier. Grounding is another critical aspect of electrical safety. A proper ground connection provides a low resistance path for fault current to flow back to the source, allowing a circuit breaker or fuse to trip and to energize the circuit. A faulty ground connection can lead to voltage leakage and increase the risk of electrical shock. Induction, as mentioned earlier, is the process by which a changing magnetic field induces a voltage in a nearby conductor. This can occur when live wires run close to neutral wires, especially over long distances. The induced voltage can be enough to cause a noticeable voltage reading on the neutral wire. Capacitive coupling is a phenomenon that occurs when two conductors are separated by an insulator, forming a capacitor. In certain wiring configurations, the capacitance between wires can create a path for voltage leakage, especially in circuits with electronic devices that contain capacitors. When troubleshooting electrical problems, it's essential to use the correct tools and follow proper safety procedures. Always turn off the power to the circuit before working on any electrical components. Use a reliable voltmeter to measure voltage and continuity. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it's best to consult a qualified electrician. They have the knowledge, experience, and equipment to handle electrical repair safely and effectively. To further elaborate on each potential cause, firstly, the cross, neutral and live conductors can occur if wires are not properly identified or labeled during installation. This can also happen if wires are accidentally switched during repairs or modifications. When the neutral and live conductors are crossed, the neutral wire becomes energized, creating a dangerous situation. This can cause appliances and fixtures to become energized even when they are turned off. Secondly, induction from nearby wiring is more likely to occur in older homes with wiring that is not properly shielded. In modern wiring, cables are often shielded to reduce the effects of induction. However, in older homes, the wiring may not have any shielding, making it more susceptible to induction. The amount of voltage induced on the neutral wire depends on several factors, including the distance between the live and neutral wires, the length of the wires, and the amount of current flowing through the live wire. Thirdly, a ground fault in the switch or fixture can occur if the insulation on a wire becomes damaged or worn. This can expose the bare conductor and allow current to flow to ground. Ground faults are more likely to occur in older homes with wiring that is not properly maintained. They can also be caused by pests, such as rodents, that chew on the insulation of wires. Fourthly, capacitive coupling is more likely to occur in circuits with long wire runs or with electronic devices that have large capacitors. The amount of voltage leakage due to capacitive coupling depends on several factors, including the capacitance between the wires, the frequency of the voltage, and the impedance of the circuit. In addition to the recommended actions outlined earlier, there are some other steps that can be taken to troubleshoot voltage leakage problems. Check for any loose connections or damaged wiring in the circuit. Loose connections can create resistance and lead to voltage leakage. Damaged wiring can expose the bare conductor and allow current to flow to ground. Inspect the light fixture for any signs of damage or wear. A damaged light fixture can cause voltage leakage or create a fire hazard. Test the circuit breaker or fuse to make sure it is functioning properly. A faulty circuit breaker or fuse may not trip when there is a ground fault, which can lead to voltage leakage. If you suspect that there is a ground fault in the circuit, you can use a ground fault circuit interrupter, also known as a GFCI, to test for it. A GFCI is a device that detects even small amounts of current leakage to ground and will trip, disconnecting the power to the circuit. GFCIs are typically installed in bathrooms, kitchens, and other areas where there is a high risk of electric shock. In some cases, voltage leakage may be caused by a problem with the electrical service to the home. This can be caused by a faulty transformer, a loose connection in the service panel, or a problem with the grounding system. If you suspect that there is a problem with the electrical service, you should contact the utility company. They will be able to inspect the service and make any necessary repairs. When working with electricity, it is important to take the necessary precautions to protect yourself from electric shock. Always turn off the power to the circuit before working on any electrical components. Wear appropriate personal protective equipment such as insulated gloves and safety glasses. Use insulated tools to work on electrical components. Never work on electrical components when you are wet or standing in water. If you are not comfortable working with electricity, it is best to consult a qualified electrician. They have the knowledge, experience, and equipment to handle electrical repairs safely and effectively. Furthermore, understanding the specific components involved in a three-way switch circuit can be helpful. A three-way switch circuit allows you to control a light fixture from two different locations. It typically involves two three-way switches and a light fixture. Each three-way switch has three terminals, a common terminal, and two traveler terminals. The common terminal on one switch is connected to the power source, while the common terminal on the other switch is connected to the light fixture. Traveler terminals on both switches are connected to each other via two traveler wires. When the switches are in the same position, the circuit is complete and the light fixture is on. When the switches are in different positions, the circuit is broken and the light fixture is off. If there is voltage leakage in a three-way switch circuit, it can be more difficult to troubleshoot than in a simple circuit. This is because there are more wires and connections involved. However, the same troubleshooting steps can be used to identify the cause of the voltage leakage. Start by turning off the power to the circuit and testing the voltage at each terminal on the switches and the light fixture. Look for any loose connections or damaged wiring. Use a GFCI to test for ground faults. If you are unable to identify the cause of the voltage leakage, consult a qualified electrician. In addition to the above, it's worth mentioning the importance of using the correct type of wire for electrical installations. The National Electrical Code, or NEC, specifies the types of wire that are approved for different applications. Using the wrong type of wire can create a fire hazard or cause other electrical problems. For example, non-metallic sheath cable, also known as NM cable or Romex, is commonly used for residential wiring. It consists of 2 or more insulated conductors enclosed in a plastic jacket. NN cable is suitable for dry locations only. It should not be used in wet or damp locations. Another type of wire is THHN wire, which is a single conductor wire with a thermoplastic high heat resistant nylon jacket. THHN wire is suitable for both dry and wet locations. It is often used in conduit. When selecting wire for an electrical installation, it's important to consider the ampacity of the wire. Ampacity is the maximum amount of current that a wire can safely carry. The NEC provides tables that list the ampacity of different types of wire based on their size and insulation type. It's also important to consider the voltage rating of the wire. The voltage rating is the maximum voltage that the wire can safely handle. The voltage rating should be greater than the voltage of the circuit. When making electrical connections, it's important to use the correct type of connector. There are different types of connectors for different types of wire and different applications. Using the wrong type of connector can create a loose connection or cause a fire hazard. Wire connectors should be listed by a recognized testing laboratory, such as Underwriters Laboratories, also known as UL. This ensures that the connectors have been tested and meet safety standards. When tightening wire connectors, it's important to use the correct torque. Torque is a measure of the force used to tighten a fastener. Too little torque can result in a loose connection, while too much torque can damage the connector. Torque specifications are typically provided by the connector manufacturer. It's also important to protect electrical wiring from physical damage. Wiring should be installed in conduit or other protective enclosures where it is exposed to physical damage. For example, wiring that runs through walls or ceilings should be protected by conduit. Wiring that runs underground should be buried at a sufficient depth to protect it from damage. In addition to the above, it's worth mentioning the importance of regular electrical inspections. Regular electrical inspections can help identify potential problems before they become serious. Electrical inspection should be performed by a qualified electrician. The electrician will inspect the wiring, connections, and other electrical components to ensure that they are in good condition and meet safety standards. They will also test the operation of circuit breakers and GFCIs. If the electrician finds any problems, they will recommend the necessary repairs. In conclusion, finding 65 volts at the light fixture when the switches are off is not normal and indicates a potential problem that should be addressed. Potential causes include a cross-neutral and live conductor, induction from nearby wiring, a ground fault in the switch or fixture, and capacitive coupling. Troubleshooting steps include turning off the power, confirming the voltage, disconnecting the fixture, inspecting wiring connections, and testing for ground faults. If you are unable to identify the cause of the voltage leakage, consult a qualified electrician. Remember to always follow proper safety procedures when working with electricity.